On July 17th, 1981, 114 people were killed in a hotel lobby in Kansas City. There was no fire, no earthquake, no explosion. They were killed by a change to a drawing, a change that nobody, not one person, at any point in 3 years, ever did the arithmetic on.
By the end of this, you'll understand exactly what that change did, why it doubled a load without anyone noticing, and why the original design, the one that was changed, was already too weak to be legal. But here's what this is actually about. There were at least 16 separate moments when one ordinary person, doing one ordinary part of their job, would have stopped this. 16. And the last one wasn't dramatic. It was a single sentence in a routine report.
Everything here comes from 3 documents. The National Bureau of Standards investigation, published in May 1982. The 442-page findings of the Missouri Administrative Hearing Commission, and the 1988 appellate ruling that upheld them. Where the record is disputed, I'll tell you it's disputed. There's a lot of folklore attached to this case, and some of the most repeated details are simply wrong. The Hyatt Regency Kansas City had been open for 12 months. On Friday evenings, the hotel held a tea dance in the atrium lobby. A big band, a dance contest, a few hundred people on the floor, and a few hundred more watching from the walkways above. It had become a local institution. That night, there were somewhere between 1,500 and 2,000 people in the atrium. A local television crew was filming. That tape is the reason we know, to the second, what happened next.
At 7:04, the band came back from their break. At approximately 7:05, a trombonist finished a solo. There was about 1 second of warning. Then the 4th floor walkway came away from the ceiling, fell onto the 2nd floor walkway directly beneath it, and both went to the atrium floor together. 71 tons of steel and concrete from 45 feet. The falling debris cut the water mains and the sprinkler lines. And here the building did something almost unbelievable. The water in those lines was fed from tanks on the roof, not from city pressure, so it could not simply be shut off at a valve. It kept coming. The lobby began to flood, and people trapped under the concrete began to drown. The fire chief ordered a bulldozer driven through the front doors of the hotel so the water could get out. They brought cranes and jackhammers inside a hotel lobby. The power was cut to prevent fires, so they worked in the dark, in the dust, in the water. It took roughly 14 hours. 29 people were pulled out alive. The last of them was a man named Mark Williams. He was trapped for about 10 hours with both legs dislocated, and he came close to drowning before they got the water down. A year later, he said, "Anger does no good. People have to live with their own mistakes." 114 people died. More than 200 were injured. Until September 11th, 2001, it was the deadliest structural collapse in American history. And now here's the number that stopped the investigators cold. They went back to that television tape and counted the people standing on the walkways at the moment of failure. Not 400, not 200. The National Bureau of Standards concluded that 63 people was a credible upper bound. 63, spread across 240 feet of walkway. That is fewer people than fit on a school bus. And most of them weren't even dancing. The tape shows them standing at the handrail, watching. 63 people, standing still, brought down 71 tons. Which means the question isn't why it collapsed that night.
The question is how it stood up for 12 months.
So let's look at the drawing. 3 walkways crossed the atrium. The second floor and the fourth floor walkways were stacked, one directly above the other. The third was on a different axis, and it did not fall. The fourth floor walkway hung from the roof on 6 steel rods, and the second floor walkway hung from the fourth floor walkway. That sentence is where everything happens, so I want to be exact about it.
In the original design, on the contract drawings, there was one continuous rod. It came down from the roof. It passed through a hole in the beam of the fourth floor walkway, and it kept going down to the second floor walkway, where it ended in a nut and a washer. So the fourth floor walkway rested on a nut partway down that rod. The second floor walkway rested on a nut at the bottom of the same rod. The rod carried both of them, but each individual connection, each nut pressing up against each beam, carried only one walkway. That distinction is the entire case.
What got built was different. Instead of one continuous rod, there were 2. A short rod from the roof down to the fourth floor beam, ending in a nut underneath it, and then a completely separate rod, starting on top of that same fourth floor beam, running down to the second floor. The 2 rods were offset by 4 inches, so they could both pass through the same beam.
Now follow the weight. The second floor walkway no longer hangs from the rod. It hangs from the fourth floor beam. So that beam is now carrying its own walkway, plus the entire second floor walkway hanging off the bottom of it. And all of that has to transfer out through one nut, pressing up against the underside of a beam.
The load didn't get bigger. The building didn't get heavier. The path got rerouted through a joint that was never meant to see it. In the original design, that connection carried 20.3 kips. As built, it carried 40.7. Exactly double.
And now the part that makes an engineer put down their coffee. That beam wasn't a solid piece of steel. It was 2 channel sections, laid on their sides facing each other, welded together along the seams where they met. Which means there was a weld line running down the exact center of the bottom face. And the hole for the rod was drilled straight through it. So the nut, now carrying 2 walkways, was pressing up against a welded seam with a hole in it.
When it failed, it didn't snap. The nut peeled the 2 channels apart and pulled up through them. Investigators found marks on the steel that told them this had been happening slowly. The nut had been dragging through the metal in small increments over months. The building had been failing since the day it opened. Just quietly.
So the fabricator changed the design, doubled the load, and killed 114 people. Except that is not what the investigation found. Here is conclusion number 7 of the National Bureau of Standards report, quoted directly. The box beam hanger rod connection would not have satisfied the Kansas City building code under the original hanger rod detail. The original design, the one on the sealed contract drawings, before anybody changed anything, met about 60% of the legal minimum. The change took it to about 30.
The change didn't create the flaw. It converted a hidden weakness into a certainty. And there's a harder version of that, which came from the engineer of record himself. Years later, lecturing about the case, Jack Gillum said, "The connection that failed was never designed. Not designed badly, not designed with an error in the arithmetic. Nobody ever did the calculation. Not once. Not in the original drawings, not in the change, not in the review. There is no point in the 3-year history of that building where a person sat down and worked out what that connection could hold. So how does that happen? Not through one villain, through 16 small, entirely ordinary failures, each one of which looked reasonable at the time.
It starts before the change. The rods were originally specified at 1 3/8 of an inch. The architect asked for them to be made thinner, 1 1/4, for appearance. A thinner rod is fine if you use stronger steel. That change required grade 60 steel. The contract drawings never stated the strength. So the rods that arrived on site were ordinary 36,000 psi steel. Nobody caught it. In June 1978, the project engineer and the senior designer both left the firm in the middle of the job. The design intent left with them. In January 1979, the steel fabricator asked to change to the 2-rod system because the continuous rod was difficult to fabricate. There's a famous story that this was approved in a phone call. I have to tell you, that is disputed. The fabricator said they called and received approval. The engineering firm said no such call ever happened. It was never resolved, and one of the most widely used case studies of this disaster explicitly instructs students to treat the phone call as an assumption for the sake of argument, not as a fact. But the phone call doesn't matter, because there is something on paper. On February 16th, 1979, 42 shop drawings arrived at the engineering firm. Among them was the drawing showing the new 2-rod connection. On February 26th, 10 days later, they went back out the door, stamped with the professional seal of Jack Gillum. The firm's own internal procedures required a detailed check of all special connections. The court found that the project engineer, Daniel Duncan, never reviewed that connection. And the court's exact language here is worth hearing. He did not assemble its components to determine what the connection looked like in detail, either on a sketch or in his mind. There's a detail in the record I keep coming back to. Daniel Duncan received his Missouri engineering license on February 27, 1979. The drawings went out with the seal on February 26th. He was licensed the day after. And then the building went up, and people kept asking. A technician at the engineering firm questioned whether the rods were strong enough. He was given a verbal reassurance by the project manager. He accepted it and never looked at the drawings. A construction worker noticed one of the box beams deflecting more than it should. He assumed steel does that. He covered it with drywall. And Daniel Duncan was asked directly about the safety of the 2-rod arrangement on at least 6 separate occasions during construction. 6 times, someone's instinct told them to check. 6 times, he told them it was fine. He had never calculated it. The commission later found that he had misrepresented the safety of that connection while being, in their words, ignorant of the safety of it. And then, on October 14th, 1979, the building tried to tell them. 2,700 square feet of the atrium roof collapsed during construction. Nobody was killed. It was a different connection, in a different part of the structure, and it had nothing to do with the walkways. But a large piece of the building had just fallen down. The architect and the owner asked for a complete review of all the steel in the atrium. The engineering firm asked the owner to pay for a full-time engineer on site during construction. The owner declined. Cost. And Jack Gillum personally assured the owner's representative that he would look at every connection in the hotel. What came back was a report. And in that report was this sentence. We then checked the suspended bridges and found them to be satisfactory. The Missouri Court of Appeals, 9 years later,
found that statement to be false. The review had not been done. Gillum read the report and took no exception to it.
That sentence was written 21 months before the collapse. The building was standing. The walkways were already hanging on connections at 30% of code, already quietly deforming under their own weight. Nobody had died yet. The tea dances hadn't started. One person with a set of drawings and an afternoon would have found it. A first-year engineering student would have found it. That is Gillum's own assessment years later.
That sentence is the last safe moment. Not a near miss. Not a dramatic warning ignored. A line in a report saying a check had been done when it hadn't. And here is how findable it was. 3 days after the collapse, the Kansas City Star hired an independent structural engineer named Wayne Lishka and handed him the drawings. He found the design change before the federal investigation announced it. 3 days, one engineer, a newspaper's expense account. The paper won a Pulitzer Prize for it.
The Warren County investigation closed in 1983 without an indictment. But in January 1986, the state of Missouri revoked the engineering licenses of Daniel Duncan and Jack Gillum and the certificate of their firm for gross negligence, misconduct, and unprofessional conduct. The judge who wrote that decision put the principle in a sentence engineers still quote. While the engineer may properly delegate the work of performing engineering design functions, he cannot delegate the responsibility.
The industry changed. Model codes now require that steel connections be observed during construction by an engineer other than the one who designed them. The idea that connection design could be quietly handed off to whoever was fabricating the steel, which was genuinely common practice in 1979, did not survive this building.
Jack Gillum spent the rest of his career giving lectures about it. He told the Kansas City Star on the 20th anniversary that it was on his mind 365 days a year, and that when he spoke to rooms full of engineering students, he was trying, his words, to scare the daylights out of them. He eventually accepted full responsibility for the collapse. He died in 2012. In 2015, 34 years later, a memorial was finally dedicated in Kansas City. All 114 names are on it. Here's what I keep thinking about. Nobody in this story was reckless. Nobody was drunk. Nobody cut a corner to save money. Nobody hid something they knew to be dangerous. Every single failure was somebody assuming that someone else had already checked. The detailer assumed the connection had been designed. The technician assumed the project manager knew. The worker assumed that steel bends like that. The architects assumed the engineer had verified it. 6 separate times. And the engineer of record assumed his own firm's review had happened and put his seal on it. If you have ever signed off on something you did not personally check, and almost everyone who has ever approved a drawing, merged someone else's code, or countersigned a form has, then you already understand exactly how 114 people died at a dance. That's the last safe moment. Next time, a machine that delivered radiation to cancer patients. It worked perfectly for 2 years. Then a technician typed too fast